Good afternoon, everyone. Thank you for clicking on this video. I'm making this video obviously for the students who received the worksheet, this worksheet limiting and excess reactant worksheet yesterday in class. Not yesterday, Friday in class. My even kids will get this worksheet tomorrow. So hopefully I help you. I'm going to do one problem with you. So we'll do one part A, B, C, and D, and then hopefully this will be a refresher and you can do the other problems on your own. Okay? So it says directions, balance each reaction first, and then answer the set of questions for each one. Circle your final answer, make sure to show all work, obviously. Okay, I hate stupid questions, so I have to show work. Of course you have to show work. Of course. This is math problems, guys. I need to see your work. Okay? So the reaction is C3H8, which is propane, reacts with oxygen to produce carbon dioxide and water. This is a clear-cut combustion reaction, just hydrocarbon, but more importantly, oxygen is a reactant. That's not important for this, but, just so you remember, because you are going to have an exam coming up, and this is going to be on it. It says balance each reaction first, meaning none of these are balanced, so you have to balance them yourself. Okay, so we're going to balance this together. If you need me to make another video on balancing, remind me, I can do that, but I already have videos posted on balancing, and there's a lot of good ones on YouTube already from other people, so I would just, refresh your memory on balancing, because if your reaction is balanced, the problems are wrong, because all of our numbers are coming from the coefficients. Remember that. So if your reaction is balanced, everything's wrong. If your reaction is not balanced correctly, everything's wrong. Okay, so C3, I have 3 carbons. I have 1 carbon. I'm going to put a 3 in front so that now I have 3 carbons. This changes the oxygens I have to 6. I'm multiplying. 3 times 2 is 6. So I want to have 6 over here. So I put a 3 in front of the O2 to make this 6. Okay, now I see that I have, sorry, I'm lying to you. 6 here, yes, and there's 7 oxygens total, because I have 1 over here as well. So I'm counting the total number of oxygens on the product side. So I have 7 oxygens. So I can't balance that yet because I have an even number. There's nothing I could put here that would make me get 7. So I'll save it for last. I actually think we already balanced this one in class, but I'll just finish it. Okay, hydrogen, H8, I have 8 of them over here, so I need 8 of them over here. So I'm going to put a 4 in front. This changes my oxygens to 4 here and 6 here, making it 10. So I just put a 5 in front of this, and there's my reaction balanced. Okay? Perfect. Part A says, if you start with 14.8 grams of propane and 3.44 grams of oxygen, determine the limiting reactant or reagent. Okay, so like I said before in class, you might see the word reagent, you might see the word reactant. Same exact thing. Okay, so how can you identify what my limiting reactant is? Very simple. Okay, it's giving you how much of each reactant we have. Remember, reactants are on the left side of the arrow, so these are called reactants. And products are on the right side of the arrow. So it is telling us that we have 14.8 grams of propane and 3.44 grams of oxygen. It's giving us the amount of reactants. In order for me to determine the limiting reactant, I have to convert these amounts to moles. Then I compare the moles of what I have, what I'm starting with, right? I compare the amount of moles that I have, what I'm starting with the amount of moles needed by the reaction. Okay, the reaction needs 1 mole of propane and 5 moles of oxygen. Okay, in order for this reaction to proceed, again, if there's no number, it's an invisible one. I need 1 mole of propane and 5 moles of oxygen to proceed with the reaction. I want to see how much I have with these numbers, so I'm going to convert them to moles first. Okay, that's how I'm going to determine what the limiting reactant is. So we'll start off with 14.8 grams of propane times a fraction, because I'm converting this to moles, and 3.44 grams of oxygen, O2, right? You're writing what's in the reaction. O2 is written in the reaction, not O, so make sure you include O2 here. Okay, times a fraction. And again, I'm trying to find moles, so moles will go on top. Okay, grams goes to the bottom. I'm canceling it out. So grams per mole, mole per gram, everyone should know that this is molar mass. How to find the molar mass? use the elements off the periodic table, use their masses, add them up together. Okay, so C3H8 over here, according to the periodic table, carbon is 12, but there's 3 of them. So 12 times 3. Hydrogen is 1, but there's 8 of them, so 1 times 8. So 8 plus 36 give me 44. So it's 44 grams per mole. 44 grams. 44 grams per 1 mole. Okay? It's like 60 miles per hour. I'm doing 60 miles in 1 hour. I have 44 grams in 1 mole. That's what that means. Okay? For oxygen, I have O2. So I have 16 times 2 gives me 32 grams per 1 mole. Okay, now I'm just going to divide these numbers and get my number of moles. So 14.8 divided by 44. 0.3363, and then 3.44 divided by 32, 0.1075. Okay, now that I have the number of moles of propane and the number of moles of oxygen, I divide them by putting the largest number on top. Okay, here's the largest number on top. 0.3 is bigger than 0.1, so I'm going to do 0.3363 divided by 0.1075. Okay, so I'm literally just going to copy and paste this over here so you can see what I'm doing. Okay, I'm going to divide these together. Divide. Okay. When I divide these two numbers, I end up getting, so 0.3363 divided by 0.1075. I end up getting 3.128 moles, who's on top, of propane over 1 mole of oxygen. Okay, think of it like this. The way that I'm doing this is, if I have 0.3363 over 0.1075, okay, and I have 4 over 2, right, I would be dividing the top and the bottom by 2 to get 2 over 1. Dividing the top and the bottom by the smallest one, and I get 3.128 over 1. Okay, so that's what this cancels out to 1, this cancels out to 1, so that's why I'm writing 1 at the bottom. Okay, so now this is how many moles we have in a ratio set equal to 1, because it's easier to visualize. This is how many moles we have, so we can now compare it to how many moles we need. Again, we were starting with this many grams. I just converted both of them to moles, and I'm comparing how many moles I need versus have in the reaction. In the reaction, I need 1 mole of propane and 5 moles of oxygen. Okay, here I have 3.128 moles of propane. Okay, so I'm going to write this here. I have versus need. Okay, I need 1 mole. I have 3.128 moles. Okay, I have 5 moles. I have 1 mole. And I need 5 moles. Okay, so what am I doing? I just took this number. So 1 mole of O2, 1 mole of O2. 3.128 moles of C3H8, 3.128 moles of C3H8. That's how much I have, because I'm starting with that amount. So again, in the reaction, I need 1. But I have 3. So that's great. I have a lot extra, right? I have extra. How do we say extra in chemistry? How do we say extra in chemistry for these types of problems? Excess. I have an excess number, so I have an excess amount of propane. Okay, but I'll keep that to the side. I have 1 mole of oxygen, but in the reaction, I need 5. So who is my limiting reactant? Who do I run out of first? Who will prevent me from making more product? The one that I run out of first, the one that I don't have enough of. Okay, so again, I need 5 moles according to the reaction, but I only have 1. I need 1 mole according to the reaction, but I only have 3.128. So I have way more than enough here, but I do not have enough here. Therefore, oxygen is my limiting reactant. Okay, so I'm going to erase all these numbers. Erase all these stuff. Okay, erase, make some space. Again, my limiting reactant is oxygen, making my excess must be that guy. whenever we're deciding who's limiting and who's excess, it's only between the reactants. Products will never be included in this. So if one is the limiting, the other one must be excess. And you already saw why it was excess. It's because I already have, I have way too much propane. I needed only one. I have 3.18. Okay, 128, whatever. So now that I can identify who my limiting reactant is, I will just put this over here. I'll leave my work for A, and I'll just, put O2 square as my limiting reactant. Same exact thing. Okay? And then I guess I'll just move this over here. This belongs to this. Okay? Next, determine the number of moles of carbon dioxide produced. Okay, carbon dioxide is a product. Here's carbon dioxide. Okay? In order for me to determine how many moles of carbon dioxide can be made, that's dependent on the limiting. The limiting reactant will tell me how much CO2 I can make. Okay? The limiting reactant will always determine how much product we can make. Because again, once I run out of this, I can no longer make product. Doesn't matter if I have 1,000,000 moles of excess. If I run out of a reactant, I can no longer make any product. So everything that I produce is determined by the limiting reactant. So I have to start off my calculation with how many moles of limiting reactant we have. Well, we said the limiting reactant was O2. I have 3.44 grams of O2. Again, I don't care about the gram number. I want the mole number. We calculated it here. We took that number, we changed it to moles. That's what I'm starting with. And I'm going to change this to, we'll see. I'm looking for what? Number of moles of carbon dioxide. To go from moles of one substance to moles of another substance, we use mole ratio. Okay, if you need the map, write out the map and follow the map. I'm not going to write it out, but to go from moles of one substance, this is moles of substance 1 because we're starting with it, and we're looking for moles of substance 2. If you look at the map, this is just a one-step problem, one fraction problem, and I use mole ratio to do it. So here I'm looking for moles of substance 2, which is moles of carbon dioxide, okay, and I'm canceling out moles of oxygen. To get the numbers in this fraction, right, moles of oxygen cancel out. To get this number in the numbers from the fraction, I look at the reaction coefficients. Moles of CO2, I have 3 moles of CO2, so I will put that 3 here. Moles of O2, I have 5 moles of O2, so I will put that there. Okay, then I will just do 0.1075 times 3 divided by 5. And that will give me 0.0645 moles of CO2. Okay, we don't really care about sig figs. Just get the right number and I'll be happy. Okay, there's my final answer. I actually don't like how this is green, so I'm going to make this red because it bothers me. Good. Okay, next question. Determine the number of grams of H2O produced. Okay, so we just found the number of moles of one of our product. Now it wants to know how many grams of the other product we'll have. Once again, it doesn't matter how much excess reactant I have. Once I run out of the limiting, I can no longer make product. So every time I want to find how much product I'm making, I have to use the amount of moles of limiting reactant. Okay, I have to. Because once my limiting reactant runs out, I can't make any more product. So it doesn't matter how much excess I have. It matters how much limiting I have. So I will always use the amount of limiting I have from the problem. I have, again, 3.44 grams of limiting, but we want to change it to moles for the calculation, which we did, this number. So we'll be using this number once again in our calculation. I will start with 0.1075 moles of O2. And now I'm looking for grams of H2O. Okay, the map goes as follows. Grams of substance 1. Moles of substance 1. Moles of substance 2. Grams of substance 2. I am at moles of substance 1 because whatever you're starting with in the problem, that's always substance 1. So we're here. We're at moles of substance 1. And we want to go to grams of substance 2. Grams of substance 2. So that's what I'm going to do. So I first need, my first fraction will go from here to there. So I'm looking for moles of substance 2 first. And again, substance 2 will always be what you're looking for in the problem. It's asking me to find grams of H2O. H2O is my substance 2. Okay, next thing I'm going to do, cancel out my moles of oxygen by putting it at the bottom. When I have moles over moles of different substances, it's called mole ratio, and I get those numbers from the reaction. Okay, moles of H2O. How many moles of H2O do I have according to the coefficient? Okay, 4. I have 4 moles. You're looking at the coefficient. And then how many moles of O2? How many moles of O2? Looking at the coefficient, I have 5. Okay, I'm not done yet. I just found moles of H2O, but now I want grams of H2O. So I'll multiply by another fraction. Okay, another fraction. Now I'm going to go from moles of S2 to grams of S2. Looking for grams of H2O here, because H2O is my S2. And I'm canceling out moles. Grams per mole of the same substance is molar mass. You can find the molar mass by adding up all of the atomic masses from the periodic table for each element. So H is 1 times 2 is 2 plus 16 from oxygen is 18. So 18 grams per 1 mole. Okay, that's just molar mass. Everyone should know this by now. Okay, and then my moles cancel out, and I'm left with grams of H2O. So then I'm going to do my calculations. I have 0.1075 times 4 times 18. Divide that by 5, and I am getting 1.548 grams of H2O is how much I can produce. That's how much product I can make. Okay? Perfect. And then, last but not least, determine the number of grams of excess reactant left over. Left. How much excess left? That's so important. Okay? How much excess did I start with? How much excess did I start with? Well, who's my excess? Propane. How much excess did I start with in the problem? It literally says if you start with 14.8 grams of C3H8. Again, C3H8 is the excess reactant, right? I started with 14.8 grams of excess. How many do I have left? Well, first I got to figure out how much I used. Once I figure out how much I used, then I can figure out how much I have left. So we're going to put this little number to the side. In order for me to find out how much I used, I have to use my limiting reactant, 0.1075 moles of O2. This is going to tell me, to the ratio of amount of moles I have for oxygen, how much propane was needed to proceed with the reaction. So I will multiply by a fraction, follow my map. Okay, first step is mole ratio. So I'm looking for moles of propane because it asks me grams. So you need to go to moles first. So moles of propane will be first. Grams will be second in the second fraction. Okay, and then I have moles of O2 at the bottom. Mole ratio. 5 moles of O2. 5 moles of O2. 1 mole of propane. 1 mole of propane. Okay, easy. Times another fraction. Okay, I'm again looking for grams of propane. The question is asking me how many grams of excess is left. This is my excess. Let's find how much grams of excess I used first. Okay, so moles of C3H8 goes to the bottom because this cancels, and then this also cancels. Molar mass of propane, grams per mole of propane. We already found that out, this number. Grams of mole of propane. That's when you take, C is 12 times 3 plus 8 hydrogens will give you 44 grams per mole. Okay, so now I have 0.1075 times 44 divided by 5. That gives me 0.946 grams of C3H8. This is how much I use. Whoa, this is how much I use. Let me move this. Okay, this is how much I use. Oh my gosh. In the reaction. Okay, and I'll write that here. Used in reaction. Because again, I had 0.1075 moles of oxygen that I used completely. I used it up all completely, right? And then to find out how much of this I had to use for the reaction, I took the amount of limiting I had and converted that to number of grams of excess, and that was able to tell me how many grams of excess I used. So I used this much. Remember, how much did we start with, though? We started with 14.8 grams. Okay? So if I started with 14.8 grams and I used 0.946 grams, how much do I have left over? I have 13.854 grams left over. Okay, so really this is not the correct answer. That's not the answer. This is just telling me how much I used in order for me to find out how much I have left. Okay, because the question's asking me how much I have left, not how much I used. Okay, again, left. How much excess reactant is left? Therefore, the final answer is 13.854 grams. Okay, and this is how you solve these types of problems. If you have any questions, let me know. It's the same exact idea for the rest of the worksheet. Okay? Thank you for watching, and have a great rest of your weekend.